In this video, I prepared a model of a wooden gate for you. We have this short or square one, and later we'll look at the long gate. I think it's going to be a very entertaining video since this is an excellent example to analyze forces. Also, this structure is very common. Everyone, if they don't have one, has at least seen a gate before. In this case, we're going to talk about a wooden gate. Here we have the diagonal. The first question is, what about here? You can pause the video and write in the comments which direction you think the diagonal should go. Going up from the hinge, this would be the hinge of the gate. Going up from this corner to this one, or going down from the hinges to the other opposite corner. What we're looking for here in this gate is stability. Ideally achieving stability with just one piece. If we put the diagonal in this direction going down from the hinges, we have a diagonal piece working in tension. And look what happens if I let go of the gate, the structure tends to collapse. That tells us that this piece is depending 100% on the hardware we use to make this connection. The hardware is the nails, screws, or plates we use to attach this piece to the frame. It's an undesirable option if we're using wood, because we're not taking advantage of the geometry. If we turn this piece around, look what happens. Suddenly, the frame becomes rigid, and the loads are properly transferred to this corner, making this piece work in compression. Something similar to what we saw in the Spanish truss, with the diagonals transferring the load to the king post. In this case, we have a much simpler structure, which is a square with a diagonal. In this case, it would be a kind of strut, since it is working in compression. Believe it or not, this is a very common mistake. Sometimes people, out of ignorance, place the diagonal like this. And over time, since the wood is soft, the nails or screws come loose and the gates tend to collapse or fall down. As I mentioned then, this piece, working like this under tension, will depend 100% on the hardware, which of course is neither optimal nor convenient. If we want to make a gate that works under tension, our best option is to use a metal piece, a steel cable. For example, ideally it should go through the wood at both corners and on the other side be fixed with some kind of nut or washer so it can be tightened. And that way, so to speak, we're pulling the corner upward. If we use wood, always use the diagonal in compression. Doing it this way, you just need a plate to keep the diagonal from coming out. You don't need to add hardware for rigidity or mechanical strength, just a couple of plates here to keep the piece in place. It's not that wood is bad when working in tension, as if we were stretching it. In fact, it's quite strong, just a little less than its strength in compression. The problem here is the geometry, not the actual strength of the wood. Metal works very well in tension and not as well in compression. That's why, for example, Japanese saws have such a thin blade, or can afford to have such a thin blade, since when we cut with Japanese saws, we pull, and when pulling to cut, the saw blade works in tension. If we were to cut with a Japanese saw, if you push, you'll notice that the metal will tend to buckle, that is, to bend. That's why European saws have a much thicker blade than Japanese saws. We work by pushing, so the blade is under compression. Now, to make this a little more interesting, let's move on to example number 2, where we have a longer gate, which is generally the type of gate you most commonly see at the entrance of a house where cars can enter. Let's see what happens with the diagonal when we have a rectangle, in which direction we need to place the diagonal, or if it goes in the same direction, what solution do we have? Because that diagonal is going to change its angle, it will no longer be a 45-degree angle like in the square example. The 45-degree angle is the optimal one. It's perfect because it's a compromise between supporting the load that comes vertically and also rigidity, since the diagonal gives perfect rigidity to the structure. Here we have to sacrifice something. In this case, the diagonal will have a smaller angle, which will give us rigidity, but it will receive the load from here in a less direct way. The most direct way to receive a load is perfectly vertical, but the balance between supporting a load and providing stability is what the 45-degree angle gives us. Here we have another angle. We can use a diagonal like this. We already know that this diagonal has to be in compression, because if we put it like we showed in the example of the other gate, This doesn't have any support. We would have to depend on the hardware again, so we already know that this has to go like this. In compression, this way this gate will work without any problems, but I think we're already at the point where we should consider another solution. This angle is so low that it's not transferring the load to this corner very efficiently. If you can imagine it, this load is, so to speak, pushing this vertical and this vertical outward. Is it putting too much force or stress on these joints? To solve this, we have two options. One would be to run a steel cable, a metal piece that connects this corner with this other one. That way, we would be working in compression with the wooden piece and in tension with the metal piece. It's a valid option, but now, since we're looking at an example of a gate made 100% out of wood, I'm going to show you the correct option. In this case, our best alternative here would be to divide our panel into two equal panels, placing a vertical one right in the middle of the rectangle. That way, we can now place two diagonals at an optimal angle. And that's how we transform our frame, our gate, into a truss, where the diagonals are working in compression. Ideal mechanical stress if we're using wood. That's how we solve the problem of a diagonal with a very low angle in a longer gate. From what length do we have to use the option of dividing the panel and putting in two diagonals? The truth is that from what I've read and studied, there isn't a definitive answer, there isn't a golden rule. Some say that once you go past the 45-degree angle, you should already use this option. I've seen other people say that if the length exceeds the height by 1.5 times, we should already switch to this double diagonal structure. I'm not a structural engineer or construction expert, just someone passionate about this structure. I think it's amazing that a piece can be very rigid and strong in one direction, and just by turning it, it can make the structure collapse. Those things still blow my mind, but my intuition tells me that it's going to depend on the material, the thickness of the pieces, and also the load. Obviously, for it to support a gate like that, so I made this example more or less by eye. I made the gate a bit longer and I realized that this angle is close to 45 actually, a little higher than 45. And it seemed to me that this diagonal is a bit laid down. We're making a wooden gate, not a place for people to live, so it's not that serious. How would I make my gate? Based on my experience with furniture, I would use this joint, which in my experience is the strongest woodworking joint, called a fork joint. This, maybe together with some weatherproof glue, plus 4 galvanized carriage bolts so they don't rust as much. Washer and nut. On the other hand, I think it would be an indestructible gate. And if it's that long, I would always use the option of the vertical and the two diagonals in compression. That's just a final note, which is more of an assembly tip, which is a topic I'm a bit more familiar with. I hope the video was useful for you and that you liked it. I really enjoy making these kinds of models. I have a great time, and I hope you like them too. I saw that the video about the Spanish truss was well received, and that motivated me to keep making these kinds of videos about structures, mechanical forces, and so on. There are plenty of things to do. We have many types of trusses and beams. Timber frame construction or traditional joinery. So if you keep enjoying this, count on me because I really like this topic. I send you a hug. Take care and see you soon in the next video. Bye.